So dear student, in this lecture we are going to discuss about rules of assigning oxidation number or oxidation state. There are various rules that we have to learn in order to find out the oxidation number or oxidation state of an element or a compound or in a molecule. So the first rule is the oxidation number or oxidation state of all the element in a free state is 0. The oxidation state of any uncombined or free element is always equal to 0. For example, if we take an example of zinc. Now zinc is a free element. What do you mean by free element? Those atoms or elements that are not bonded, chemically bonded to any other atom, those are known as free element. For example, zinc. As you can see, zinc atom is not bonded to any other atom, so its charge would be 0. This is the first rule for assigning the oxidation state, which says that element in free state would have always 0 charge. Similarly, if we have sodium atom, now it is also in a free state, so its charge would be 0. Its oxidation state would be 0. Similarly, hydrogen atom is in a free state, so its charge is 0, its oxidation state is 0. Similarly, if we take in another example, that is for sulfur. Sulfur exists in S8 form. This is the allotropic form of sulfur. So now in this case, sulfur atom is having 0 state. Hydrogen always exists in a diatomic molecular form. So as we know that it is composed of 2 hydrogen atoms, so hydrogen atom in hydrogen molecule have 0 oxidation state when it is in a free state. Similarly, sodium have 0 charge, zinc have 0 oxidation state. Now we will study the second rule for assigning an oxidation state, which says that the oxidation number of an ion consisting of a single element is the same as the charge on the ion. Now what do you mean by this? For example, sodium is represented by a symbol Na. Now when it will form ion, it would be converted into positive 1 charge. Similarly, if we have calcium and if it loses its 2 valence electron, calcium belongs to group 2a, so whenever it loses its 2 electron, valence 2 electron, it would be converted into calcium ion. So whenever you have a simple ion, these are known as simple ion. This is simple ion, sodium ion is a simple ion. Similarly, calcium is a simple ion. So in simple ion, oxidation state is same as their charge. For example, oxidation state of sodium in Na positive 1, and similarly for calcium positive 2 is positive 1 and positive 2 respectively. As you can see that sodium ion have positive 1 oxidation state, O.S is for oxidation state, and calcium have positive 2 oxidation state. Now it is known as simple ion because it is composed of only one element. It is not in a combined state. That is why it is known as simple ions. Now we have the third rule, which is about the complex ion. In a complex ion, the total sum of oxidation state or oxidation number of atom is equal to the charge on their ions. For example, if we take an example of carbonate ion, CO3 negative 2 charge. Now this negative 2 charge is on the whole ion. Now this is known as complex ion. Here we have discussed that these ions are composed of only single elements, so these are simple ions. While in this case, as you can see, that carbon atom is bonded to 3 oxygen atoms, so this is known as complex ion. Now in case of complex ion, we have a charge that is -2 in case of carbonate ion. The sum of oxidation state of carbon and 3 oxygen atom, as you can see, in case of carbonate ion you have 1 carbon atom and 3 oxygen atoms. So the sum of oxidation state of carbon and 3 oxygen atom is equal to -2. So the sum of oxidation state of 1 carbon atom and 3 oxygen atom is equal to -2. Similarly, if we have another complex ion, that is NH4, and as we know that NH4 is known as ammonium ion. Now it is also a complex ion because it is composed of nitrogen and 4 hydrogen atom. Now if we have 1 nitrogen atom, as you can see in the molecular formula for ammonium ion, we have 1 nitrogen atom that is bonded to 4 hydrogen atom. Now the sum would be equal to +1. The sum of oxidation state of 1 nitrogen atom and 4 hydrogen atom is equal to +1. Now this +1 is the oxidation state for ammonium ion. This +1 is the oxidation state for ammonium ion. Similarly, this -2 is the oxidation state for carbonate ion. Carbonate ion and ammonium ion both are complex ions. Now we have rule number 4 for assigning oxidation state, which says in neutral molecule the algebraic sum of the oxidation number of all the element is equal to 0. Oxidation number of each of the atom in a molecule or a compound is counted separately and their algebraic sum is always equal to 0. For example, if we have hydrochloric acid, which is HCl, so the sum of oxidation state of hydrogen and chlorine atom is equal to 0. As we know that in this case we have +1 charge on hydrogen atom and -1 charge on chloride ion. So this is hydrogen atom, hydrogen ion, and this is chloride ion. So the algebraic sum would equal to 0 because +1 and -1, that is equal to 0. So what does this mean? It means that hydrogen chloride is a neutral molecule because the sum of its oxidation states are equal to 0. Similarly, if we have carbon dioxide, now in case of carbon dioxide, oxygen atom is having -2 charge, while carbon atom is having plus 4 charge. Now how their algebraic sum is equal to 0? As you can see that carbon atom is having positive 4 charge, while you have two oxygen atoms. So once you multiply 2 with minus 2, once you multiply 2 with minus 2, you will get minus 4. Now why you have multiply 2 with minus 2? As you can see that oxygen atom is having minus 2 charge. How many oxygen atoms are there? You have 2 oxygen atoms, so you have to multiply this 2 with the charge with the oxidation state of oxygen atom. So 2 multiplied by minus 2, you will get minus 4. So plus 4 and minus 4, you will get 0 as the answer. So it means that carbon dioxide as a whole is a neutral molecule. Similarly, if you have water, so in case of water, oxygen atom is having minus 2 charge, while hydrogen atom is having positive 1 charge. So once you multiply this 2 with plus 1, you will get 2 multiplied by plus 1, so that is equal to plus 2. And oxygen atom, as you can see, have minus 2 charge. So this is for hydrogen, and for oxygen you have minus 2 charge. So plus 2 minus 2, what you will get? You will get 0 as a algebraic sum. So it means that water molecule as a whole is neutral in nature. So the rule number 4 says in neutral molecule the algebraic sum of this oxidation number of all the element is equal to 0. Now we have the fifth rule, which says that the oxidation number of different elements in a periodic table, in group 1 it is plus 1, in group 2 it is plus 2, and in group 13 it is plus 3. So here we have a periodic table in which, as you can see, that this is the group 1A, this is group 1A, and similarly this one is the group 2A, this is group 2A, and similarly as you can see that this is group 3A. So in case of group 1A, these elements have positive 1 charge. These elements always have positive 1 charge except for hydrogen atom. And similarly group 2 elements, they have positive 2 charge, and similarly for group 3A they have positive 3 charge. In case of group 3 elements, we can take an example of BF3, boron trifluoride. So now in case of boron trifluoride and fluorine we have minus 1 charge, and similarly on boron we have positive 3 charge. So 3 multiplied by minus 1, you will get -3 for fluorine, and boron have +3 charge. So as you know that the algebraic sum is always equal to 0. So -3 and +3 you will get 0. So it means that group 3A have +3 charges. Similarly, if we study an example for group 2A, so in group 2A we can take an example of magnesium chloride. Magnesium chloride. So as you know that chlorine have -1 charge and magnesium have +2 charge. So 2 multiplied by -2, you will get -2 for chlorine, and magnesium have +2 charge. So they would cancel out, and as a result you will get 0. Algebraic sum would be equal to 0. In case of group 1A, you can take an example of, you can take a simple example, simplest example, that is sodium chloride. As you know that sodium belongs to group 1A, so it have +1 charge, and chloride have -1 charge, so +1 and -1, that gives you 0 is the answer. So oxidation number of different element in a periodic table is: group 1A have +1 charge, group 2 have +2 charge, and group 13 have +3 charge. Now we have the sixth rule for assigning an oxidation state, and which says that oxidation number for hydrogen in all of its compound is +1, but whenever it forms metal hydride, its charge or its oxidation state is equal to -1. Now what do you mean by this? First we will talk about metal hydrides. That what is metal hydride? So whenever metals react with hydrogen atom, whenever metals react with hydrogen atom, they will form metal hydride. They will react to form metal hydride. So in case of metal hydride, hydrogen have -1 charge. For example, if we have sodium, now as you are more familiar that sodium is a metal, so whenever it is reacted with hydrogen, so it would form metal hydride. This is known as sodium hydride. Now in this sodium hydride, sodium have +1 charge, because as we have studied in the fifth rule for assigning the oxidation state, that sodium atom belongs to group 1A, so it have +1 charge. So hydrogen will have -1 charge. So +1 and -1, they will cancel out. Algebraic sum would be 0. So keep in mind that whenever sodium binds to metals, the compound so formed would be sodium hydrides or metal hydride. Particularly in case of sodium, it would be sodium hydride, or if it bond with any other metal, so that would be metal hydride. So we can take in another example, that is magnesium hydride. Now in this case, magnesium belongs to group 2A, so it have +2 charge, and hydrogen have -1 charge. So 2 multiplied by -2 for hydrogen and +2 for magnesium, so algebraic sum is equal to 0. Now Other than metal hydride, hydrogen atom will have positive 1 charge. For example, if it react with hydrogen fluoride, so hydrogen fluoride have, in case of fluorine you have minus 1 charge, in case of hydrogen you have plus 1 charge. In case of water, since fluorine, in this case fluorine is not a metal, similarly whenever it make a water molecule, when it is reacted with oxygen, it give water. So in this case hydrogen also have positive 1 charge. So keep in mind this rule for hydrogen, that whenever it form hydride it will give minus 1 charge, and other than metal hydride, it will give positive 1 charge. Now this is rule number 7, and according to this rule the oxidation number of oxygen in all of its compound is -2, but it is having -1 charge in peroxide and +2 in OF, oxygen fluoride. OF2, it is actually OF2. So whenever it form peroxide, it is having -1 charge. For example, if we have H2O2, now this is hydrogen peroxide. So as you can see that oxygen is not a metal, so if it is not a metal, so hydrogen
atom have positive 1 charge. Here you have 2 hydrogen atoms, so 2 multiplied by positive 1, it will give positive 2 charge. Similarly, in case of oxygen, here you have 2 oxygen atom have -1 oxidation state, so 2 multiplied by -1, it will give
as a
-2
whole,
charge.
as you can see that oxygen atom is having -1 charge whenever it is making peroxides. So in case of peroxides, oxygen atom is having -1 charge. Now if we have OF2, this is oxygen difluoride, so OF2. Now in this case fluorine is having -1 charge and oxygen is having +2 charge. So whenever it form difluorides, oxygen is having positive 2 charge. Now other than peroxides and difluoride, oxygen atom will have -2 charge in its compound. For example, if we take an example of water, so in case of water, oxygen have -2 charge, and in case of carbon dioxide, oxygen also carries -2 charge. In case of carbon monoxide, oxygen have -2 charge. Now there are certain elements in a binary compound whose oxidation state very rarely change. These are the elements of group 1A. Group 1A have positive 1 charge, group 2 have positive 2 charge, group 3 have positive 3 charge, and hydrogen atom, as we have discussed earlier, that whenever it form metal hydride, it is having -1 charge. Other than this, it always have positive 1 charge. Group 7th, those are known as halogens, and as you are more familiar with halogens, that these are the member of group 7th, like fluorine, chlorine, bromine, and iodine. So these have -1 charge, and in case of oxygen, as we have discussed in detail, that it always have -2 charge except in peroxide and oxygen difluorides. So this was all about rules for assigning in oxidation states.